Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to begin our discussion talking about the idea of color. Specifically, what color is and how we produce color in cartography. So first of all, let's talk about what color is. Right, what is color? So from a sort of physics perspective, right, color is this idea that we have electromagnetic radiation, which we typically call light, hitting our eye. And the wavelength of that electromagnetic radiation is going to determine what color our eye perceives that light to be. Right? So sort of in classic physics, right, you'll see something that looks kind of like this, right, where we have a wave of protons moving in a direction, and we have this classic peak and trough shape, and we have this distance from one peak to another, and we call this distance wavelength. And so without going too far into the weeds here, we have things like the sun or a light bulb that are engineered, or in the case of the sun, chemically designed or chemically created to produce energy, right, light, at all kinds of wavelengths. So we have blue, green, red, yellow, purple, right, the rainbow, right, all those different wavelengths, all those different colors are different wavelengths, right, they're different distances between one peak and the next. And our eyes are, again, right, our eyes are designed to interpret specific wavelengths as specific colors. So the idea with cartography is that we're trying to manipulate that energy so that our eye only sees certain wavelengths. So that therefore we see certain colors. And there are two ways we can approach this, right? So that's what color is, right? Color is just light that is at a specific wavelength that our eye is designed to detect. And so how do we actually do that, right? How do we produce color? Right, how do we produce color? Well, there's two ways that we can do this. There's the additive method and the subtractive method. Let's go ahead and talk about the additive method first. Right, the additive method of color production. And this is the one that we're probably using most often in everyday life, because this is the way that our computer monitors and our TVs produce color. So what we can do is we can think of the additive method, right? You can think of having a computer monitor, right? This is a monitor, or a TV, or whatever device you're looking at. It could be a phone screen, right? We have some sort of monitor, and that monitor is broken up into pixels, right? Right, when we talk about 1080p, right, that's a certain number or a certain ratio of pixels, right? And each pixel in the back of it has three little diodes, right? At least the method I'm describing does. There are different ways to approach this, but the end result is always the same, right? We have a diode that produces blue, a diode that produces red, and a diode that produces green. Right, so each pixel has these own little things that produce red, green, or blue light. Right, so unlike the sun or your light bulb in your lamp, right, these are designed to specifically emit only a key few wavelengths of light. Right, each one of these little diodes produces a key few wavelengths of light. The blue one here produces just blue wavelengths. The red one produces just red wavelengths, and the green one produces just green wavelengths. And so what will happen here is, as we communicate through our GIS software what pixels we want to make what color, and we'll talk about how we do that communication in the next couple of videos, but what happens is we stimulate these to produce their wavelengths in some portion. And so, for example, if this pixel here were to only produce the red diode, if only the red diode produced light, right, it would only produce red wavelengths. And so we have our eye over here, right, our eye over here. We have our eye. And what would happen is the eye would get that red wavelength coming in, right? It would perceive it as red on the screen. Okay, that seems pretty straightforward, right? Red being produced, red being seen. Let's talk about what happens maybe in a different pixel down here, where we have that same arrangement of red, green, and blue producing elements, right? Blue, red, and green producing elements. So this is capable of producing, again, those same three colors, red, green, and blue. And let's say this one, instead of just producing red, it produced, let's say, blue and green in equal measure. Right, so it produced green and blue. Right, so we have blue and green light coming in from this particular pixel here. What's going to happen is our brain is going to get these. It's going to interpret them as adding together. Right? You can think of this when you were a little kid and you used to mix paint. Right? It's the same kind of process here. We're adding blue and green. When we add blue and green in an additive color scheme, what we end up getting is a color called cyan. Right? So red and green combined by our eye, we see as cyan. So that's why it's called additive, because what happened was we added these two colors together. And as a result, we created this new color called cyan. Whereas in this instance, we only produced red, so we only saw red. Okay? That's the additive method. We're combining colors together to create more colors. So let's talk about subtractive. The subtractive method. So this is the method that we use in printers, for example, when you buy color ink. Right? When we buy color ink, we're using the subtractive method because that ink is going to do something that is very different from what we did with our monitor. So with the subtractive method, what we have, instead of a monitor directly producing light, we have an external light source, right? That light source, if you're outside, is going to be the sun, right? If you're inside, not by a window, right, that light source is going to be a light bulb, right? So this would be our little light bulb here. Its little filaments, right? This is a light bulb, light source. Right, we got a light source that's producing light. And now, just like I said earlier in the video, right, the sun and our house lights, right, our typical indoor lighting, right, it's designed to produce all of the wavelengths that we typically see. Right, so it's producing red, green, blue, yellow, everything, right? It's producing everything. Whereas with the additive method, we were only producing red, green, and blue, and we were adding them together. What we're doing with the subtractive method is we have a light source that's producing everything. It's producing all the wavelengths. And instead what we're doing is we have a piece of paper. Right, we have a piece of paper. And on that paper, there's going to be some ink. And so what's going to happen is, as we have light coming in of all the different wavelengths, it's going to hit that ink. And that ink is going to be designed to absorb, right, or subtract wavelengths out. It's going to keep those wavelengths contained in the paper. And then others are going to be allowed to bounce off or be reflected. And what's reflected is what hits our eye, and we end up with that same process we talked about earlier, where our eye is going to perceive those wavelengths as color. So let's go ahead and take a look at what would happen under this scenario. Right, so we have, let's just say we had red. Again, this is going to be producing all different wavelengths of light. Red, green, blue. Right, it hits the paper. The paper has combination of cyan and has a combination of magenta and yellow. So magenta and yellow inks. It has a combination of magenta and yellow ink. What would happen is the magenta and the yellow ink would absorb the green and the blue, and the red would be reflected off. And so our eye, right, our eye would see red. Right, and that's because down here, right, the magenta and the yellow ink absorb all but red light. Right, so we're literally subtracting out all the other colors. Right, additive, we were producing and combining. Subtractive, we're removing the other colors. And the reason that I said magenta and yellow ink is because the subtractive color method uses colors to absorb, whereas here where I said red and blue produce cyan, that's because the additive colors combine. So the last thing that I want to talk about is white and black. So for the additive color method, white light happens when we emit all the wavelengths. So in the additive method, right, white light is when all wavelengths are being emitted. Right, so if we were to think about it like this, or if we were to draw sort of circles here, right, red, blue, and green, right, where they all overlap, this is going to be our white. Where we have red and green overlapping is going to be our yellow. Where we have green and blue overlapping, this is going to be our cyan. And then finally, where red and blue overlap, this is our magenta. Right, so white light happens when all of the wavelengths are being emitted. Black light happens when none of the wavelengths are being emitted. So let's go ahead and talk then about what happens down here with subtractive. Right, subtractive, right, our primary colors that we're using, because we're dealing with ink, is magenta, is yellow, magenta, and cyan. And where all three overlap, we get black, right? Because if we have all three of these inks put on top of each other, we're actually producing black ink. Right? We're mixing together the three, we're absorbing everything, nothing is escaping. So our eye would see no color. Where we have cyan and magenta overlapping, this would be where we would get our blue. Where we have our yellow and our cyan overlapping, this would be where we would get our green. And where we have magenta and yellow overlapping, this would be where we would get our red. So I know especially the subtractive method can be a little bit confusing, and that's really okay because in all reality, we're not really dealing with this far down in the weeds too often. It's just really good to know that basic at a fundamental level, computer monitors, the digital formats, produce their color differently than the physical formats. That's the key thing I want you to take away. Digital methods use the additive model, physical formats use the subtractive model. So hopefully this all made sense. And as always, if you have any questions, please reach out. Thank you.